This is the AP Stat Course Check number 1 review for the quizzes that you guys took the other day. Some of these problems I will just verbally answer and talk about what percentage of you got it right and wrong, and some of them we will have to do on paper. I will be putting various reminders and little formulas as well, whether we need to or not. So why don't we get started? I'm looking at number 1. Number 1, example of a histogram, very straightforward. 100% of you got that question right, so oh, happy day. Number 2, however, we run into a little bit of an issue. On number 2, it looks like only 39% of you got this one right. Not most of you. Yeah, most of you. Most of you pick symmetrical. But the problem that you run into is the fact that this itty-bitty little piece right here is all the way to the right. Now, it may be considered an outlier, but if you were to draw a curve over top this thing would be skewed to the right. Unfortunately, I can't call it symmetrical. Number 3, what is the IQR of the data set? Now, just for the sake of argument, I'm going to be writing this down on my piece of paper. I'll switch over the camera in a moment. Now, obviously, I could probably just do this in my head or throw this into a calculator and have it do it for me. But indulge me for a moment, and let's just see what we're going to get here. For this problem, here's our data set. There are 9 data points. The exact middle data point is your median, and then the middle of the left side would be your Q1. The middle of your right side would be your Q3. Halfway between those 2 points would be 45. Halfway between those 2 points, well, no brainer, 54. If you're finding your IQR, that would just be Q3 minus Q1. So your answer should be 9. And according to this, it looks like half of you, 50% of you, got this one right. You got to be careful of those kinds of things. Of course, you could do this directly in the calculator, where if by some chance you're like, oh, I'm just going to type all this data in and then run a 1var stat and scroll down, it can give you your Q3 and Q1, and then you just simply subtract them to get 9 again. So there we go. Let's take a look at number 4. On number 4, what percent does each of the 4 sections contain on a box and whisker plot? It looks like every single one of you got this one right. So, oh, happy day, the answer is 50%. Let's scroll down to number 5. Number 5, they want to know what is an example of categorical data. Categorical data, as I've tended to remind you, you cannot take an average. It doesn't make any sense to take an average of categorical data. Categorical data, the answers just fit into categories. In this case, a high school graduate or not, that would be a yes or no question. Categories. Everything else, annual income, years of schooling completed, years of playing an instrument, it makes sense to take an average of those. Number 6. Now, number 6, we will have to do a little bit of a calculation because they want z-score. So, we're going to have to go back to our top-down. Now, z-score can be described in many different ways. The critical value, per se. But a z-score would be the data point minus the average divided by the standard deviation. Now, for this particular problem, it looks like they gave me a mean of 22. I'm just going to write this in as I'm reading it. A mean of 22, a standard deviation of 3.1, and an x value of 29. So if I were to do that calculation, it looks like I should be getting 7 over 3.1, whichever my calculator says at this point, would be approximately 2.258. If I were to go back to my choices, 2.258 would give me an answer of A. Let's see, how many of you got that one right? Most of you. got that one right. The vast majority of you, looks like 89% of you got that one right. So again, oh, happy day. Let's take a look at number 7. Now number 7, similar problem with a z-score. Looking at the percentages, it looks like only 44% of you got this one right. 44%. Let's just see where things kind of pan out. I'm going to flip over to my top-down menu so you can see me writing this out for this problem. But they say they want the mean with a z-score at negative 1.4, an x value at 20. Forgive the formatting on the problem. That's really weird. Minus whatever the x bar was. We don't know what the mean is. And a standard deviation of 7. If I were to solve that, I would multiply both sides by 7. Negative 9.8 equals 20 minus x. You could subtract 20 and then divide by negative 1. You should be getting an x bar of 29.8, which is the answer and is what 44% of you got correct on that problem. So good for you. Number 8. On number 8, they want you to describe the correlation in the graph shown. And again, 100% of you, strong positive. The correlation is the direction of the linear line of best fit. I shouldn't say linear line of best fit, whatever. But it would be the line of best fit, and it's positive, it's sloping upward. It's strong because they're very closely clustered. So we're good there. What letter do we use to represent the coefficient, or sorry, the correlation coefficient? Again, this is just a definition. R would be your correlation coefficient. Not to be confused with r squared, which is another lesson, but we'll get into that. Now r, just for the sake of argument, this goes into number 10, because only 72% of you got it right on number 10. R can be measured from negative 1 to positive 1, with negative 1 and positive 1 being perfect correlations, either a perfect negative correlation or a perfect positive correlation. R equal to 0 would be absolutely no correlation whatsoever. That would be the weakest. So if we're talking about negative 0.87, that is a strong correlation comparatively to moderate and weak. It's a moderate would be, I don't know, anywhere from like 0.6 to and lower to like 0.25 or something like that, or 0.75 to 0.25. Anything above 0.75 is considered strong or fairly strong or something along those lines. So let's take a look at number 11. Now, number 11, they wanted you to estimate the value of R. And it looks like 83% of you got this one right. It was definitely negative, which puts you down to either B or D. Negative 0.99, that would be almost a straight line. They're clearly not in a straight line. They're not that clustered. The answer's got to be D, negative 0.27. 83% of you got that one right. 83% of you got number 12 right as well. How do you calculate a residual? It's observed minus predicted. Observed minus predicted. If the data point lies above the line of best fit, you would have a positive residual. You would subtract their y values. The predicted line would be that line of best fit. Number 13. What type of correlation exists between the temperature outside and the number of hot chocolates sold at a football game? Now, 67% of you got this one right. But let me flip back to this screen real quick, just to kind of give you a visual. Visual. Sure. They want to know the temperature outside. Temperature outside. So this would be the temperature going up. It would get hotter and hotter and hotter. And this would be the number of hot chocolates sold. And this would be the number going up and up and up and up and up. The idea being, the hotter it gets, likely the less hot chocolates are going to be sold. Sometimes it helps to see that kind of visual. The hotter the temperature, the lower the number of hot chocolates being sold. 67% of you got that one right. Let's see. Let me flip the screen back. There we go. And let's take a look at number 14. There we go. Number 14. Kim surveys 100 moviegoers that enter the movie theater in the first hour. What type of sampling method is this? Number 14 looks like 56% of you got this one right. It's definitely not random. It's definitely not random. Now, convenience or biased. Biased sampling, well, that's what convenience sampling is. But it's biased. So, there we go. But the definition, the actual vocabulary definition would be convenience. 56% of you got that one right. Just like number 15, 56% of you got this one right as well. A large company wants to conduct a survey to determine the proportion of its male employees who practice yoga on a daily basis. 2 of its regional offices are chosen at random, and all of the male employees at each office are surveyed. The plan is an example of which type of sampling? Okay. They want to determine the proportion who practice yoga. 2 of its regional offices are chosen at random. So theoretically speaking, each regional office supposedly would be a representation of the population of the company. Each regional office would represent a slice of the company, and the slice would be a good representation of what the whole company looks like. This is an example of cluster sampling. Cluster. The reason, well, let's look at what you chose. Some of you chose simple random. It's definitely not simple random. It's not systematic. Systematic would be like picking every 10th person based on some kind of maybe alphabetical list or some junk like that. I don't know. Or based on some level of randomness. Stratified sampling would be breaking up the company into different strata, and each strata would have something in common. I go back to the Boston cream pie example. If you take the Boston cream pie and you separate it into its individual components, the Boston, the cream, the chocolate, and then sample a little from each, that is stratified sampling. But if you take a slice of that pie, you're going to get a good taste of everything. The slice is going to be representative of the whole thing. The answer is cluster sampling. Let's take a look at number 16. I hope some of you laughed the moment you read this. Joe Mama wants to do an observational study comparing height and weight. He also does a study comparing weight and calories consumed. He concludes that the more calories you consume, the more you weigh. And people who weigh more are generally taller. Therefore, if you eat more, you get taller. Why is this incorrect? 72% of you picked the correct answer. Correlation does not indicate causation. This is what it comes down to. A control group has nothing to do with the control group. In fact, control groups are typically done with experiments. What does A say? Causation from one observational study cannot be extrapolated and applied to another. Be that as it may, the answer is correlation does not indicate causation. Number 17, every single one of you got this correct. Every possible group of units of the required size has the same chance of being the selected sample as any other sample of the same size. That is simple random. That is just a pure definition of simple random. Hopefully the other choices that they gave you there were an indication that they were wrong. But that is the pure definition of simple random. Let's take a look at number 18. Get my windows straight. There we go. Number 18. Looks like every single one of you got this right. This sample, is selected by dividing the population into subgroups or strata, even though the problem doesn't say it, and then taking a fixed number of units from each group using the simple random sample. That's the pure definition of stratified sampling. Number 19, 83% of you got this right. 83%. A company states that 2% of its computers are returned for defects. We take a sample of 100 computers to find the probability of 10 being defective. Is this a binomial distribution? Now, with a binomial distribution, very similar to geometric in a sense, there's obviously a key difference between the two. But these are what we call Bernoulli trials. Bernoulli trials is basically there's two outcomes, two definitive outcomes, yes or no, or whatever this thing ends up being. In this case, defective or not defective. So this is definitely a Bernoulli trial, but does it come down to being a binomial? If it were a binomial, we would have a finite number of trials, or the finite possibility of successes and failures and stuff like that. They're taking a sample of 100 computers, so the answer is yes. Since there's a fixed number of independent trials, again, key being independent trials, outcomes come in two categories, and the probability of the defect is constant. Absolutely. Let's flip this down to number 20. Let's see what we got here. Number 20, looks like 61% of you got this right. On an 8-question multiple choice quiz with 4 answers for each question, what is the probability of guessing and getting 6 correct answers? Well, I'm gonna have to go to my top down for a moment. Let's see. There are 8 questions and 4 answers to each question, so there is a 1 in 4 chance of getting the problem correct, I should say. Now, they want to know the chances of getting 6 correct answers. Probability of success, number of trials, number of successes that they are looking for. This is a binomial problem. In fact, since you are, what's the word I'm looking for? You're trying to get exactly 6 successes. This is a binomial PDF. And of course, this is something that we're going to study in good detail. I'm going to have a review day on a probability, and I'm going to spend all that time talking about, well, not all the time, but some of the time talking about binomial and geometric. But the order that I would type this thing in, it would have to be N, P, X. Let's see what the calculator says. If I'm going binomial PDF 8, 0.25, 6, that gets me approximately 0.0038, which rounds to 0.004, which was the answer to this particular question. Let's look at number 21. Number 21 comes with a visual, and they want to know what is the probability of sandals. There's no given statements, there's no and, there's no or, which of course we will review at a future date. But it looks like there are 20 sandals out of 36, which puts us at approximately, well, if I do 20 divided by 36, that's 0.5 repeating. Now, this question's a little bit unfair. Just a little bit unfair. Because if you look at the choices that they give you, 20 out of 36 is clearly one of the choices. However, it is not reduced. It's not reduced. I know this is kind of a, what's the word I'm looking for? This is kind of a unfair, kind of wrong answer that you got here, but the answer has to be 5 out of 9. I know, it's one of those things. Otherwise, every single one of you did it correctly. It's just that only 22% of you picked 5 out of 9. I know, unfortunate. This didn't count against you, so no worries. Number 22. Find the area under the standard normal curve where z is less than 2.42. Let me flip to my top down. If I'm talking about the standard normal curve, with 0 being right in the middle, there's 1, there's 2, there's 3 standard deviations above the mean. We're looking at about 2.42 and less. This is a lot of the curve, a lot of that curve. So it basically comes down to two choices. Is it 0.992 or is it 0.862? If you do normal CDF with just 2 inputs, normal CDF automatically assumes that you're typing in z-scores. Normal CDF, small number, comma 2.42, 0.992. 61% of you got this right. 61%. Let's change back here. And let's go down to number 23. Now number 23. In the formula shown, what is the denominator? Now, to be very specific, some of you chose sample variance, which that is definitely not variance. I don't know what you were doing with the sample mean and individual score. This is your sample standard deviation. And the reason why it's a sample standard deviation, number 1, they're using an S. Number 2, it's X bar, which is the sample mean. They want to know what is in the denominator. It is the sample standard deviation. 72% of you got this right. Let's look at number 24. What is the probability that a family doesn't have a baby girl until their 3rd child? This is an example of a geometric problem. A geometric problem is you're looking for a first success. What is the probability that a family doesn't have a baby girl until their 3rd child? Meaning on the 1st child they got a boy, the 2nd child they got a boy, and then on the 3rd child they finally got that girl. Each trial independent of the next. That's a 1 out of 8 chance, which if we're talking decimals, 0.125, which rounds to 0.13, 78% of you got this right. 78% of you got this right. Let's go down to number 25. On number 25, looks like 61% of you got this right. And this came down to simple, the main difference between those who got it right and those who got it wrong, it was the difference between PDF and CDF. The vast majority of you picked a B or D. The vast majority of you picked a B or D. So the probability that Jalen makes a free throw is 75%, 0.75. What is the probability he makes his first free throw on the 3rd attempt, 3? He makes his first free throw on the 3rd attempt. He's looking to get the first success on exactly that attempt. That is why it's a PDF. If it was cumulative for the CDF, it would say on or before the 3rd attempt or something similar to that. 61% of you got that right. Number 26. Let me just cue this up. I can't fit 28 in. Oh well. On number 26, 56% of you got this right. Given the probability model in the table below, what is the expected value? Expected value. Again, something we're probably going to be reviewing in the next few weeks. Expected value of the random variable. Well, I'm going to be writing down some of this information on my piece of paper, and then I'm going to be switching to the top-down model. There we go. Looks like there is a 10% chance of a result of 50, a 30% chance of a result of 20, and a 60% chance of a result of 5. If you simply multiply these 3 together, and then add them. What is that, 11 plus 3? The answer is 14. Another way of doing that, if you really wanted to be, I don't know, weird about it. Obviously, I don't know why you would do this with just 3 results, but you could type these results into L1 and L2. L2 being the probability or the chance of those things happening. You could run a 1var stat, but you would have to remember to do L1 comma L2, and it would spit an X bar of 14. 56% if you got that right. Number 27. Change the screen back. There we go. A coin is flipped 3 times. If you get tails once, you get $5. If you get tails twice, let's do this. If you get tails twice, you get $15, and tails on all 3 flips will get you $40. What is the expected amount of money you will get? Interesting. Your coin is flipped 3 times. Okay. So let's go here for a second. Now, they don't say it, but I'm assuming that if you get 0 tails, you get no money. I'm just assuming. So let's see what we got. You can get heads, heads, heads. You can get heads, heads, tails. You can get heads, tails, heads. There's a much. Well, yeah. I'm just gonna go with the straightforward way. There's multiple ways to explain this, but I'm just gonna go with the straightforward way. There's the 1 tails. Here are the 2 tails. And here are the 3 tails. These are all the possible outcomes with flipping a coin 3 times. So, if you get a tails once, you get $5, which there's a 3 in 8 chance of that happening. If you get a tails twice, you get $15, which there's a 3 in 8 chance of that happening. And you get a tails on all 3, you get $40, which is a 1 in 8 chance of that happening. And I'm assuming you get $0 on this 1 in 8 chance as well. Let's just go straight to the calculator with this one. Yeah. 0 times 1 divided by 8, which clearly, why would I do that? Plus, you can't see what I'm doing. There you go. 5 times 3 out of 8 plus 15 times 3 out of 8 plus 40 times 1 out of 8. Looks like you get exactly $12.50 on average. Expected value is just basically if this game were played many times, then on average people would walk away with about $12.50. 56% if you got that right. Let's jump to number 28. Let's change the window again. There we go. Good. On number 28, the Gallup poll asked a random sample of 1785 adults whether they attended church during the past week. By the way, 94% of you got this right. I just want to specify. 94%. Let p hat be the proportion of people in the sample who attended church. A newspaper report claims that 40% of all U.S. adults went to church last week. Suppose this claim is true. What is the mean of the sampling distribution of p hat? Now, just to specify a couple things. P hat is the sample proportion. We do not know what the p hat of that particular sample is. That one sample of 1785 adults. We don't know what the p hat is. We do know that the claim of 40% of the population were told, suppose the claim is true. If you were to take that sample of 1785 and you were to repeat that sample many times and then made a histogram of all of the results, look at the question. The sampling distribution of p hat. Well, in theory, it should have a mean of 0.4. That's just the pure definition of it. Anyway, number 29. Number 29, 83% of you got this right. What happens to the shape of the sampling distribution as the sample means of n increases? This is the fundamental theorem of statistics. This is the central limit theorem. Obviously, we're talking about sample means. As the sample size increases, it definitely becomes more normal, but it becomes more narrow. It becomes more narrow. You have more and more and more data points that fit closer and closer and closer to the center of that normal distribution. So it does become more narrow. Number 30. Flip that screen over. There we go. Come on, you. For number 30, these symbols represent the mean and standard deviation for which of the following? 67% of you got this right. This is the sample. X bar was just the flat-out sample. Now, you'll see the difference for this and the next problem, or the next couple problems, I should say. But yeah, this is just of the sample, not the sampling distribution. X bar might potentially be a data point in that sampling distribution, but X bar would just be the mean of the sample. Now, if you look at 31 and 32 side by side, hopefully this becomes a bit more clear. You're talking about the mean of the samples. When you do the fundamental theorem of statistics, you're talking about the distribution of the means. You take a bunch of different samples, and you have like an average from those samples, and then you make a distribution of the means. 31 is talking about the sampling distribution. The mean of X bar, the sigma of X bar. That would be the sampling distribution. 61% got that one right. And then number 32, this breaks my heart. Only 56% of you got this right. Number 32, those symbols are of the population. That was the population. Oh my. Let's take a look at number 33. Number 33, a random sample of 49 medical doctors in LA showed that they worked an average of 53.1. Now hold on, 53.1 is a sample mean, and 7.2 is a sample standard deviation. If the California average is 60 hours a week, so they're saying if this is true, if 60 hours a week is the population mean, does this give evidence, or does that sample of 49 medical doctors, does that sample give evidence of LA doctors working significantly less than the rest of California? What test should be used? You do not know the population standard deviation. You don't. And since you don't know the population standard deviation, you have to use a t-test. Now, some of you chose a t-test for a proportion, probably because you didn't read it close enough. But if you have proportions, you're going to be doing a z-test. The answer was A, one sample t-test for a mean. Let's look at number 34. Scroll that down. USA Today reported that in 1992, 39% of all elementary school students claimed that when they grow up they want to do something to help other people. Good for them. However, in 1995, 128 of a random sample of 317 of these same children showed that when they grow up they want to do something to help other people. Ooh. Okay. Does this information indicate that there's been an attitude change either way? Which test should be used? Most of you said 2 sample Z. 50% of you said 2 sample Z. Okay, you tell me, what's the sample size in 1992? What are the what's the fraction that got you 39% in 1992? 39% is just what they reported. That's their claim. They don't say anything about a sample. Maybe they did do a sample, maybe they did a survey, maybe they did a poll, who the heck knows? But 39% is the assumed claim. Then a sample was taken in 95. This is a one sample z-test. This is a one sample. 28% of you. 28% of you got that one right. Good for you who got that one right. Let's look at number 35. Number 35, the manager of a sporting goods store offered a bonus commission to his salespeople when they sold more goods. A new manager dropped the bonus system for a random sample of 6 salespeople. Man, that sounds familiar. It's almost like you had a free response on this. For a random sample of 6 salespeople, the weekly sales are shown in the following table. I know the formatting was messed up. I apologize. With and without the bonus system. Salespersons 1 through 6 with the bonus and then without the bonus. And their differences. What test should be used? Yes, technically there were 2 samples. But the 2 samples are not independent of each other. Because it's the same salesperson, both with and without the bonus. They're not independent. You have to do matched pairs. 67% of you got this right. 67%. Let's go down to number 36. Good, I fit number 37 as well. Number 36. Dannon is supposed to put 29.6 grams of fruit in their fruit-flavored yogurt. To see if enough fruit is being placed in cups of fruit-flavored yogurt, a quality inspector measured the amounts in 27 containers. She found an average of 28.9 grams, that's a sample average, and a standard deviation of 2.8, that is a sample standard deviation. Does this show that there is probably enough yogurt in the cups? What test should be used? This is a one sample T. You do not know the population, standard deviation. A few of you picked B. A few of you said one sample Z for proportion. There's no proportion here. Proportions are categorical data. This is quantitative data. You can take an average. Number 37. Almost all of you got this right. Almost all of you. 89% of you got it right. Margin of error. Margin of error is everything after the plus or minus, which is your critical value, which is either your Z star or T star, times the standard error, however that's calculated. Number 38. Now, number 38, I'm a little bit sad. What does it mean when a test is statistically significant? It's statistically significant. You have enough evidence to show that it's statistically significant if you can reject the null hypothesis. The answer is C. The test statistic has a p-value lower than alpha. So, anyway, number 39. Scrolling down. How can you reduce both type 1 and type 2 errors? It looks like 83% of you got this right. Increase the sample size. If you increase the sample size, you lower alpha and beta. Finally, I'm looking at your answers for number 40. And I have to say, I am disappointed, to say the least. Some of you apparently have not seen Star Wars. You make me sad. You make me very sad. Next, some of you went with the obvious answer being Empire Strikes Back. Empire Strikes Back is clearly the better movie out of all of them, in terms of how it's made. If any, and some of you, not some of you, I think it was just, nope, it was a couple of you, it was about 3 of you. 3 of you picked episode 6. Half of episode 6 is good, only half. If you remove the Ewoks, episode 6 is much better. Just saying. Um, and I was very interested that any of you picked numbers 1, 2, and 3. Like a couple of you picked 3, which, okay, I'm okay with 3. 3 is a good movie. I'm sorry to the person that picked episode 2. You're wrong. You're just wrong. Any acceptable answer would have been episodes 4 and 5. 4 or 5, I should say. 4 or 5. If you picked 3, okay, fine. If you picked 6, you're wrong. If you picked 1 or 2, you're wrong. Just saying. I would highly recommend seeing Rogue One. Rogue One was not one of the choices, but it was very good. I just watched Solo. It was okay. And episodes 7, 8, and 9, the jury's still out. Maybe I'll make a video with my opinions, but the jury's still out. Anyway, thank you for joining us on this journey of reviewing this quizzes, and we'll be in touch soon.